morning to every one of you. I am Dr. K. Kannan. I am handling the subject optimization techniques for you, for which the course code is MAT 433. In the next 15 to 20 minutes, I will be introducing what exactly the content of optimization techniques, what we are going to study in this semester, and what are the chapters in the optimization techniques, what for they are, how far the chapters are important from the perspective of computer applications, and because of programming such type of mathematical models as projected in optimization techniques, what is advantage, what is the direct connection of this to data science and other applied subjects. All these things I will give a very brief introduction to you now, after which I am likely to start the transportation and assignment models first. The unit 1 is linear programming. In that, transportation and assignment problems come at last, but I am choosing that as a first for making the learner easy to follow what exactly a transportation problem is, what exactly an assignment problem is, how those problems can be extended to linear programming problem, so that linear programming problem can be understood via transportation and assignment problems, not directly through mathematically, but also through some simple problems, so that linear programming can easily be followed when inequalities and non-restricted variables are present there from the perspective of computational models in mathematics. Now, the objective of this, main objective of this optimization techniques is to make the learners to expose to mathematical techniques which are essential in managing the resources. So, majority of this delivery of these lectures ought to be taken place from the perspective of problem solving. So, how can you improve the problem solving ability in optimization techniques? That is part 1. Part 2, how do you program this so that you can ask the computer to solve problems of big size arising from each of the chapter. That is the second focus. Now, as far as the first focus is concerned, the mathematical part of this is important, for which problems of different types need to be solved so as to fix the concept and learn the concept in a different way, so that how computations are taking place, what are the elegant computations that you have to do, how to track a problem or how to formulate a problem. Once the problem is formulated, what is its mathematical description? Once the mathematical description is given, then how to solve that with some handy computations, then how to write algorithms, then supported by some software codes, so that the data is fed to the computer, it will give you the answer in no time. So, that is the idea behind this optimization techniques syllabus. Here we will have 5 chapters. Number 1, linear programming. Number 2, network models. Number 3, integer programming. Number 4, inventory models. Number 5, queuing models. Linear programming, it can be defined in a different way. You know what's a variable? You know what is a equation? You know what do you mean by inequality, right? So what we are going to deal with linear programming is that there will be a function expressed in the linear form of variables, linear combination of variables, which need to be either maximized or minimized, subjected to certain constraints in the form of inequalities, together with the variables involved in that. For example, x1, x2 greater than or equal to 0. This is a non-negative restriction given there. Inequality is like 2x1 plus 3x2 plus 5x3 less than or equal to 8. Like that it could be. So subject to these constraints, how to maximize it. That is what the linear programming looks at. Then this is followed by transportation problem. Transportation problem mainly deals with transporting so many items from so many origins to so many destinations with unit cost of transportation from one ith origin to jth destination given in the table form. That is what is called a transportation problem. When we take up transportation problem, I will start from the simplest transportation problem, and as time passes by, the degree of difficulty of solving this problem is going further. How to solve that with the elegant method, that also will be taught. Next one, that is followed by assignment models. Next one is network models. In that we will have minimal spanning tree problem, shortest route problem, maximal flow problem, and the PERT CPM. That means project evaluation review technique and the critical path method. Which activity should precede which activity, which activity will succeed that activity, and how the activities can be connected by nodes, and time estimate of each faculty, each activity is given, how to find the critical path from the first activity till last activity, so that all intermediate activities can be covered within the time span. And the probability concepts are also associated to that. That is a project. When the normal time of completion of project is so much, what is the probability that the project can be completed in less time or some more time? That type of application also comes there. This is also an easy chapter. Actually, all the 5 chapters are easy chapters. And their applications are very high. When I come into the units, I will tell you what are the applications. Now I am just covering the titles. Integer programming. Already we have got linear programming. Now if the linear variables involved there is not assuming fractional values, only integral values, then that programming is called integer programming. Once again, whose application is fast, that also will be dealt while I teach this chapter. Inventory model. You know what is an inventory? What is an inventory? Physical stock of goods is called an inventory. There are 3 basic costs associated to a inventory control problem: holding cost, ordering cost, like that. One more cost, shortage cost, and other costs are also there. So when such costs are associated to the physical stock of goods, how to plan so that the total cost of the maintaining this inventory is minimum. This is posed as a problem because holding cost and the replacement of holding cost and ordering costs are inversely proportional. When holding cost increases, ordering cost falls down. When ordering cost increases, holding cost falls down. So that is the case. Then can we group all such costs with the inventory units available, so that and can we make this as a minimum one? That is what is called a basic inventory model. and that has been categorized into production and purchase models with and without shortages. Then how to introduce probability to this so that it can be called as a probability inventory model. All those things are coming in inventory model. Then queuing model. How do you define a queue? Queue is lack of service. Suppose more and more persons are coming for service, then we have to form a queue, or else there will be quarrel among them, who is to come first, who is to be served first, like that. So they have to form a queue. This queue length is going higher and high, and what we will do, we will find we have to invest much time to serve the entire queue, entire men coming in the queue. So what do? We include one more man in the service channel. The queue will be split into two, so that the entire queue can be served with less amount of time. So when this is the case, how can be the queuing model? Can that be a Poisson model? What do you mean by steady state? Measures of performance. What do you mean by specialized Poisson process, non-Poisson processes? And how these problems coming in queuing models can easily be solved either by increasing the service channel, men available in the service channel, or dividing the queue, or according to time we make the service channel to be multiple channels and so on and so forth. So this is called the queuing model. So this, what I told you so far are the basic 5 models of the optimization techniques. And you have got a variety of reference materials too. Tahai, Operation Research. Swarup Gupta, Manmohan Operation Research. Sultan and Sons. Panir Selvam, Operation Research. Sharma JK, Operation Research. Winston WL, Operation Research. And Gillett, Introduction to Operation Research. These are all the references suggested. Online materials also is suggested in the syllabus. Now, sir, I am studying this optimization techniques. Where exactly I am going to apply this optimization technique? That may be the question from you. First of all, whether it is a business problem or computer problem or optimization problem or whatever the problem it is posed, you must identify under which category, whether linear programming, network model, integral programming, inventory control, queuing model, replacement, under which category does it fall. After identifying this, then you are identifying the variables involved in that and formulate that problem as in a standard form, either in a matrix form or in a graph form or in a network form, how to identify all those variables and the problem behind it in the standard form. That will tell you that will give you the clarity of understanding this problem. Once the problem is formulated, then only the method of solving problem comes in. So according to the title, there are very many methods are available in the syllabus. I will start one by one, so that I will and at the end of each chapter I will consolidate what are all the methods, and I will put some questions to you, and I myself will answer some of the questions. Some of the questions will be given to you as an assignment. Once you solve the assignment sums and submit, I will correct and provide the correct answer to you. And more the interest you are showing towards this subject in terms of assignments, participating in quiz, participating in other things, then you will have deeper knowledge into the subject, and the understanding of each chapter will be easier to you. And some of the MCQ questions and some of the essay type questions will also be given to you for practice. You can practice so that you can solve this problem in less amount of time when they are asked. Now, coming to the transportation and assignment problems, what we are going to see in the lectures. First I will give you some small examples for transportation problem, and I will tell you how transportation problem is solved by obtaining the initial basic feasible solution and to move towards the optimal solution of this problem. As far as transportation problems are concerned, you will have three methods of obtaining initial basic feasible solution. Mind you, the transportation problem is considered to be fully solved only once you obtain initial basic feasible solution plus optimal solution. If you stop with initial basic feasible solution only, then it is only partially solved. So you have to solve totally. So moving towards optimality is carried out by Modi method. Obtaining initial basic feasible solution for a transportation problem is covered by three methods. One is northwest corner rule, second one is least cost method, third one is Vogel's approximation method. Now we will start solving the simplest transportation problem of order 2, so that you will learn all the methods for obtaining initial basic feasible solution. Now we are getting into transportation problems as the first model for a few problems to be solved, where the problems are of less size for understanding the basic models. Then we will proceed to some complicated models of higher order problems, to not only for finding initial basic feasible solution, but also to move towards optimality via Modi method. Now to introduce the transportation problem, let me take a 2x2 transportation problem as shown in this table. Now we have two origins and two destinations. Origin 1 have 60 items of a particular commodity. Origin 2 have these 50 items of the same commodity. Now these 110 items are to be transported to destination 1 and destination 2, where the requirement at destination 1 is only 45 units and the requirement at destination 2 is 65 units. With for transporting 1 unit from origin 1 to destination 1, the cost of transportation is 6 rupees. Similarly, for transporting 1 unit from origin 1 to destination 2, 7 rupees is needed. Similarly, for transporting 1 item from origin 2 to destination 1, 3 rupees. From origin 2 to destination 2, 4 rupees. Now question is, how much units of the same commodity should be transported from 2 origin to 2 destinations, so that the total transportation cost is minimum. This is what is called a transportation problem. We can generalize the statement of the transportation problem. How? The total cost of transporting so many items from so many origins to so many destinations, where the number of destinations need not be equal to number of origins, with the unit cost of transportation being displayed over a table like this, is called a transportation problem. That way we can generalize the definition also. Define transportation problem. Further, the answer is this. Now let us solve this problem, small transportation problem, for finding initial basic feasible solution. The initial basic feasible solution may be calculated from northwest corner rule, second one least cost method, third one Vogel's approximation method, and each method has got its own merits and demerits, which we will see later. Now in this present session, we will find the initial basic feasible solution using northwest corner rule first. Then I will tell you how to apply least cost method to find the initial basic feasible solution, which needs to be followed up by Modi method for moving towards optimality, for which we will take some bigger sized problem. Okay. Now for this figure, what is the northwest cell? North is on D1 D2 side, west is on O1 O2 side. So the northwest corner is this, that is O1 D1, where the demand is 45 units, supply is 60 units. So supply the entire demand 45. This is possible. Now since the entire 45 units are satisfied, I can cross this demand column. Next one, the next destination D2 requires 65 items. Now next northwest corner is, north is that, west is this. So since we have moved to this, next northwest is this. These two cells are crossed, and against northmost is D1 D2, westmost is O1, whereas this cell is already filled. So next northwest is this only, where the demand is 65, but supply is 60 minus 45 is 15 only. So 15 units to be filled up here, for which now the supply is over, 45 plus 15, 60 is over, so I cross this. Now the demand for destination 2 is 65 minus 15, and again we have 50, that 50 is available here. Now put this 50 here. Now 45 plus 15, 60, 45, 45, 15 plus 50, 65, 50, 50. So all the demand and supply are satisfied. Now since total demand equal to total supply, because what is total demand? 45 plus 65, 1 ton. What is the total supply? 60 plus 50 equal to 1 ton. Since this is the transportation problem is balanced one, is a balanced transportation one. If this is not equal to, then it is unbalanced transportation. Okay. Now the northwest corner rule we have filled. So what is the total cost because of this northwest corner rule being applied to this transportation problem? 6 into 45 plus 7 into 15 plus 4 into 50. So how much? 270 plus 105 plus 200, that is 575 rupees. Okay. Now we will apply least cost method for the same problem. Okay. Now for least cost method to be applied to this, first we pick the least cost in all cell. What is the least cost? 3, where the demand is 45 and the supply is 50 units. So I can supply all the 45 demand. Okay. Now the demand is satisfied, so cross the demand. Now what is the next least cost? Next least cost is 4, where the demand is 65 units, but supply is 50 minus 45, only 5 units. So 5 units can be supplied here. Okay. 5 units can be supplied here, so supply the 5 units. Now 45 plus 5, 50 is satisfied, so cross this. Next least cost in this one is 7, where the demand is 65 minus 5 is 60. 60 is available here, simply supply the 60 here. So now all the demands are satisfied, and again we have applied a least cost method to this 2x2 transportation problem. 60 into 7, then 5 into 4, then 45 into 3. How much? This is 420, this is only 20, this is 135. So answer is 575. Now you look at this, allocation. There are different allocations. Here 45, 15, whereas here it is 60. Now in this unit cost 3, nothing is allocated. Here in this unit cost 3, 45 is allocated. Though it is so, least cost method provides only the same solution what NWC provided. Generally least cost method will provide better solution to northwest corner rule, because we go by least cost of transportation. Here fortunately or unfortunately they are equal, but in general least cost method will provide you up to some extent least cost. Now to tell you what is Vogel's approximation, let me take this 3 by 3 transportation problem where supply are 60, 40, 50 units and demands are 45, 55, 50 units with a unit transportation cost distributed over the table like this, right. Let us first solve this using northwest corner rule in a quick manner. Now what is northwest? O1 D1, where the demand is 45, supply is 60. I can satisfy all the demand, so I can cross this demand. Next northwest cell is this O1 D2, where the demand is 55, but the supply is 60 minus 45 is 15 units. So 15 we can supply, and against this supply is over. Next northwest cell is O2 D2, where the demand is 55 minus 15, 40. So supply is also 40. So I can put 40 here. Supply also out, then demand is also can be taken off, right. Now next cell is this unit, this cell that is O3 D3, where the demand is 50, supply is also 50. So I can supply this 50. Now let us verify the rim requirements. 45 plus 15, 60, 40, 40, 50, 50. Come to column 45, 15 plus 40, 55 and 50. So NWC is now is over. So what is the total cost for this northwest corner rule? We will have 8 into 45, 6 into 15, 5 into 40, then 1 into 50, 700. Okay. This is the total transportation cost by northwest corner rule. Now let us solve this problem by least cost method. Now let us solve this using least cost method. What is the least cost? 1, where the demand is 50, supply is also 50. So I can supply both all the demand at 50 units. So supply out, demand is also out. Now among this, which is the least? 5 is the least, where the demand is 55 units, supply is 40 units, so I can supply entire 40. So this is over. Now among the rest of the cells, 6 is least, where the demand is 55, 40 units have already been supplied. So I can supply 15 units from that, so as to satisfy is 55, so this is out. Now here the demand is 45, supply is 60 minus 15, 45, so 45 can be supplied, right. Now I have supplied all the demands. Now I verify 45 plus 15, 60, 40, 40, then 50, 50, 45, 45, 55, and 50. Now I can go for calculations. 45 into 8, then 15 into 6, then 40 into 5, then 50 into 1. These are all the cell costs. Now what is this? 360, 90, is also 200, this is once again 50. So we are having fortunately LCM equal to northwest corner. So let us take some other problem for least cost method and northwest corner rule to be applied. Okay. Now let us solve a 2 by 3 transportation problem with where the demands are 60, 70, 20, and the supply are we have 55, 95. So that you will have 150 here, 150 here. You will have destination 1, destination 2, destination 3, origin 1, origin 2, right. Let us first solve by NWC method. Now since the total demand equal to total supply, it is a balanced transportation problem. Now we go for NWC. In northwest corner is this, where the demand is 60, supply is 55, so all the 55 can be supplied. So what is over? Supply is over. Now next northwest corner is this, where the demand is only 5 units. You can supply 5 units here, and again all the 60 are over, so I cross out this. Next northwest corner is this, where the demand is 70 units but the supply is 90 units, so I can supply every demand there, so this is over. Now here the demand is 20, supply is also 20, 95 minus 75 is 20, so 20. Now what is the total transportation cost? 55 into 8, 5 into 3, then 70 into 4, then 20 into 1. So what is the answer? 440, this is 15, this is 280, this is 20. So total transportation cost with respect to northwest corner rule is given by 5, 10, 11, 15, 1, 1, 2, 3, 7. Am I right? So let us solve this problem by least cost method now. Let us adopt least cost method for this problem. So what is the least cost among this? 1. So where the demand is 20, supply is 95, all the 20 can be supplied, and against demand is over. Now next least cost is 3, where the demand is 60 but supply is 75, all the 60 can be supplied, so this is over. Then next least cost is 4, where the demand is 70 but supply is 95 minus 80 is 15 units only, so 15 units can be supplied, and against the supply is over, 75 plus 20, 95. Now further demand is 70 minus 15 is 55, so all the 55 can be supplied, so 55 plus 15 is 70, similarly 55 dollars. So this is also over. Now 55, 55, then 60 plus 15 plus 20, 95, 60, 15 plus 15 is 70, 55 plus 15 is 70, then 20. Okay. Now let us go for total transportation cost using least cost method. So least cost method you have only 535 rupees, whereas in northwest corner rule you have got 755 rupees. So now I have clearly distinguished northwest corner rule and the least cost method in terms of cost also. Least cost method provides only 535 rupees, whereas northwest corner rule go for 755 rupees. So next one is what is called Vogel's approximation method. That Vogel's approximation method can also be taught with the help of the same 2/3 transportation problem, which we will go now. Now let us go for Vogel's approximation method for the same problem. Now Vogel's approximation clearly tells that we have to choose least and the next least for each row and each column. So for the first row, what is the least one? 3. Next least 5. What's the difference? 2 units. The second row, what's the least? 1. Next least 3. Difference is 2 units. For the first column, least is 3. Next least is 8. So difference is 5. For the second column, 4, 5. Difference is 1. For the third column, 1, 3. Difference is 2. This is the first step for applying Vogel's approximation method. Then we have to go for greatest of the differences. What are the differences? 2, 2, 2, 2, 1, 5. Greatest difference is 5 units. So in this column, go for least cost and supply as many demand as possible. So 95 is the supply, 60 is the demand. So you can supply entire 60 units. So demand is out. Next, once again we go for differences. So since these two are not taken, we will have the same difference 2. Here difference is 3 because this is taken off. Only these two are available. Now here the difference remaining as it is. Here also as it is. Among this greatest difference is 3. Now this least cost is 1, where the demand is 20 units. You can supply all the 20 units because 20 plus 60 only 80 comes, not 95. So this demand is also being satisfied. So I am crossing this. Now in row or column, no need to go for differences because in row 5 is the only element present. In second row also only 4 is the element present. In second column also only second column is difference is there 1. So since we are not going for the differences, we can directly choose this column and choose the least element and see the demand. Demand is 70 units for this. But the supply here is 60 plus 20, 80, 95 minus 80 is 15 units. So you can supply these 15 units. So 60 plus 15 plus 20, 95 is satisfied. So I can cross this. Now only available cell is these 5, where the demand is 50 minus 15, 55. So I can supply all the 55 units. Now all the demands and supply are satisfied. 55, 55, 60 plus 15 plus 20, 95, 60, 55 plus 15 is 70, then 20. Now what is the total cost with respect to Vogel's approximation method? 55 into 5, then 60 into 3, then 15 into 4, then 20 into 1. Now what is the total cost? 275 here, 180 here, 60 here, then 20 here. Now 5, 535. So what we have from least cost method, we are having the same thing in Vogel's approximation method. So we will have one more transportation table of order 3 by 3, where we will have different answers for northwest corner rule, least cost method and Vogel's approximation method.